So, when you're dealing with massive data warehouses, you're basically walking a tightrope. On one side, you've got this critical need for, Fort Knox level security, and on the other, this constant demand for lightning-fast access. If you get that balance wrong, you're going to be in a world of trouble. So the question is, how do you build a fortress that's also a superhighway? Let's break it down.
To really get why security is such a big deal, let's just throw a number out there: 94 million. According to Statista, that's how many data records were leaked across the globe in just a single recent quarter. I mean, that's a staggering figure, and it really hammers home the very real, very immediate threats that we're all up against. And this really gets to the heart of it. Security expert Dinesh Asaka puts it perfectly here. Data warehouses are high-value targets. Just think about it for a second. They're not just another system on the network. They are the central vault, right? It's where you put all the sensitive data from all these different sources. It's like putting all of your company's crown jewels in one place, which of course makes protecting that vault priority number one.
So how do we actually go about protecting this digital treasure chest? Honestly, the best way to think about it is like you're building a fortress. And it's not about having one single giant wall. It's about creating multiple, really smart layers of defense.
Okay, so every good fortress has layers, right? Ours is going to have 4 key ones. First up, access control. Think of these as the gatekeepers right at the front door, deciding exactly who gets in and where they can go. Next, encryption. These are our secret codes, the stuff that makes our data completely unreadable to anyone who shouldn't be seeing it. Then, we've got monitoring. Our watchtowers, constantly scanning the perimeter for anything that looks even a little bit suspicious. And finally, compliance. This is the rule book that makes sure our fortress is built to code, meeting all those legal and industry standards.
Now, the whole foundation of our gatekeeper strategy is this really powerful idea called the least privilege principle. It's a core concept in security, and it's actually pretty simple. Every single user gets only the absolute minimum level of access they need to do their job, and not one bit more.
And this really boils it down perfectly. You give an employee the key to their own office, right? You don't give them the master key to the entire building. It's just a logical approach that massively reduces your risk, because it limits the potential damage if one of those keys ever gets compromised.
So how do we actually manage all these keys in the real world? Well, we use a few essential tools. Role-based access control, or RBAC, basically automates the whole process by assigning permissions based on job titles. So analysts get analyst permissions, managers get manager permissions, and you don't have to do it all by hand. Then you add multi-factor authentication, MFA. That's like needing a key and a fingerprint scan to open a door. And finally, we use data-level security to make sure that even when someone has access, they can only see the specific rows and columns of data that are relevant to them.
All right, next up, encryption. This is our secret code, and it is absolutely crucial to understand that we need to protect data in 2 different states. In transit is when your data is moving across the network. Think of it like an armored car. We use protocols like TLS, the same tech that secures your online banking, to keep it safe on its journey. At rest is when the data is just sitting on a disk, like gold bars in a vault. And for that, we use super strong encryption standards like AES 256 to keep it locked down tight.
Okay, the fortress is built, but we can't just, lock the doors and walk away. We have to man the watchtowers. This means keeping detailed audit logs, which give us a crystal clear record of who accessed what and when. It means setting up intrusion detection systems. Think of them like digital tripwires that are always scanning for unauthorized access. And, so important, it means setting up automated alerts to ping us the second any suspicious behavior is detected so we can jump on it immediately.
All right, so our fortress is locked down tight. The data is safe. But here's the big question. What good is all that security if it takes forever for anyone to get the information they actually need out of it? This brings us to that second pillar, speed. And that's where part 2 comes in. If security is our fortress, then performance, well, that's our superhighway. We have to design a system that lets our data travel from the warehouse to the user as fast and as efficiently as possible.
So what's the magic trick here? The key engineering technique for building this superhighway is something called partitioning. In the simplest terms, it's the art of taking a gigantic single table of data and breaking it down into smaller, much more manageable pieces, kind of like splitting a giant encyclopedia into individual volumes.
So why go through all this trouble? Why build these superhighways? Well, there are 3 huge benefits. First, it massively improves query performance.
Instead of searching one enormous table, the system can go straight to a small, relevant section. Second, it makes data management way easier. Archiving or deleting old data is as simple as just dropping a single partition. And finally, it enables parallel processing, which is like opening up new lanes on our superhighway, letting multiple queries run at the same time without causing a traffic jam.
Okay, so how do we actually design these partitions? It's not just random. There are different ways to do it, but they all start with two core blueprints for building out these data superhighways.
The two big ones you need to know are horizontal and vertical. Think of horizontal partitioning like dividing a table by its rows. The classic example is splitting a giant phone book into two volumes, one for A through M and another for N through Z. Vertical partitioning, on the other hand, divides a table by its columns. This is like taking your customer spreadsheet and splitting it into one table with just names and emails and a totally separate one with less used stuff like their home addresses.
Let's make this super concrete with a sales data example. Before partitioning, you've got one massive table with sales from every single year. If you want to see 2023 sales, the system has to scan every single row. It's slow, it's inefficient. But after we partition by year, the system knows exactly where to go. It just jumps directly to the sales_2023 partition, ignores everything else, and spits out the result in a fraction of the time.
So, when does this make the most sense? Well, horizontal partitioning is an absolute rockstar for time series data. Anything with a timestamp, really. Think logs, sales transactions, you name it. It makes data management a breeze. Need to get rid of old data? Just drop the old partition. And like we just saw, it makes any query based on a date range incredibly fast.
Now let's look at that second blueprint, vertical partitioning. Imagine a customer table with columns you use all the time, like name and email, sitting right next to huge, rarely used columns like a long bio or a photo. By splitting them vertically, most of your queries are now only going to hit that small, fast customer basic table, which makes things way more efficient.
Okay, that was a lot. So let's boil it all down into a super simple checklist. First, build your fortress gates with strong role-based access control. Second, encrypt everything. Protect that data whether it's moving or just sitting there. And third, design your data superhighway by really analyzing how your data is used and choosing the right partitioning blueprint to get maximum speed.
Look, balancing security and speed isn't a one-and-done project. It's something you always have to be thinking about. So, as we wrap up, the real question you gotta ask yourself is this. Your data is your most valuable asset. Is its fortress ready for whatever comes next?